Hi, this is Mr. Mack. I'd like to talk to you today about the concept of graphing inequalities that contain two variables. Now, let's start with a simple concept here. For example, if y is equal to 1/2 x plus 3, that would be a linear equation, and the graph of that linear equation would be a line. It would have a slope of 1/2. It would have a y-intercept of 3. So the line would look something like this. Notice it goes through 3 on the y-axis, and every time we rise 1, we have run 2, or change in y over change in x is 1 over 2. Now, so y equals 1/2 x plus 3 is this line. Now, the line actually splits the plane into two halves. There is the half that is, quote, above the line, and there's the half of the plane that's below the line. Now, it turns out that the half of the plane that's above the line, all the points in that half plane satisfy the inequality y is greater than 1/2 x plus 3. And all of the points in the half plane that's below the line satisfy the inequality y is less than 1/2 x plus 3. So the fundamental concept that I would like you all to understand is that an equation, an equal sign in two variables, gives you a line or a curve that splits the plane into three parts: the line itself, and the part on one side of the line or the curve, and the part on the other side of the line or the curve. Now, the way we differentiate between the line and the two planes is the line or curve will have the equal sign, and then the two half planes will have the inequality signs. Now, you have probably done some of this in the past, and you've learned that if you have greater than or equal to, that you would draw a solid line or curve, or if you have just greater than, it would be dotted. And that is because if we had y is greater than or equal to 1/2 x plus 3, that would mean that we have both the region above the line and the line itself. But if we just had y is greater than 1/2 x plus 3, we have the part above the line, but the line itself isn't part of the set of points that satisfy it. It's just the edge. Now, what this does then is this says that anytime you have an inequality in two variables to graph, what you do first is you focus on the equation. In other words, change the inequality to equal and actually graph the line or the curve, and then figure out which side of the line or the curve is the part that needs to be shaded. You also then need to make sure that you have graphed the line or the curve as solid or dotted depending upon what inequality you have. So let's take a look at a couple of examples. Let's start, for example, with a linear inequality. We'll just make one up here. Let's say we want to graph 3x plus 2y is greater than or equal to 12. Now, what we do is we start by focusing on the line. This is a line because the line that's the edge of this plane, and that would be 3x plus 2y equals 12. Now, when we get this line, we're going to graph it as solid because we have the equal sign. We have greater than or equal to. We have the equal included in this. Now, if you have a graph or if you have an equation in standard form, one of the easiest ways to graph the line is to just find out where it crosses the x-axis and where it crosses the y-axis. Remember, and this is important, To find an x-intercept, you put 0 in for y. So if you take this equation, 3x plus 2y equals 12, and you just put 0 in for y, the 2y goes away, and you get 3x equals 12, so x equals 4. That's a very easy way to find the x-intercept. Now to find the y-intercept, we just put 0 in for x. We get 2y equals 12, so y equals 6. So the line is actually going to be right here. Now, I have written this, I've drawn this line as solid because, and I said that already, because we have the or equal to included. Now, the last thing we need to do is we need to decide which side of this line is actually represented by the inequality 3x plus 2y is greater than or equal to 12. So, what you do is you say, all right, it's one side or the other. Let's pick a point that's not on the line. Usually, when it's available, we like to pick 0, 0. Put in 0 for x and 0 for y. Now, if that makes the inequality true, that point is on the side of the line you want to shade. If it doesn't, then you want to shade the other side. Now, if we do this, we put 0 in for x and 0 in for y, we get 3 times 0 plus 2 times 0, which is 0, is greater than or equal to 12. Now, that's not true. So what we'll do is we will shade the other side of the line. Now, since 0 is not greater than or equal to 12, we do not want the side that contains the origin. We want the other side. So we would shade this region up here. Now, that shading represents all of the points that will satisfy or make true the inequality 3x plus 2y is greater than or equal to 12. Now, it doesn't have to be a linear equation in two variables. It can be an equation, or it can be an inequality like, well, let's just try, for example, y plus 3 is greater than or equal to the absolute value of x minus 2. Now, once again, what we'll do is we'll first graph, and let's just make it greater than, not greater than or equal to, because the last one we had was greater than or equal to. So what we're going to do now is we're going to think y plus 3 equals absolute value x minus 2. And what we do first is we would subtract 3 from both sides. We get y equals absolute value x minus 2 minus 3. Now, what that means is we have the absolute value graph, and it's going to be shifted 2 to the right because this minus 2 inside, by transformations, that's something we just learned, we'll shift it 2 to the right, and then this minus 3 outside, we'll shift it down 3. So actually the V, or the vertex of the graph, will be down here, and the graph will look like this. Now, once again, the question is, which side of this dotted line, or dotted curve, do we want to shade? Well, it's pretty clear that 0, 0 is on the upper part of this dotted curve, so we could use 0, 0. And if we do, we put 0 in for y and 0 in for x, and we get 3 is greater than 2. And that is true, so that's the side we would want to shade in. So we shade this side right here, and that graph represents all the points that make that inequality true. Now, this concept, or this basic idea of graphing the curve or straight line and then checking which region or regions actually make it true and shading those regions works, it can be extended to quadratic inequalities and quadratic relation inequalities. Any kind of an inequality in two variables, you can do it this way. So that's the concept that we're dealing with this time, and have fun with the problems.